On the Chapter 6 test, there's an opportunity for some extra credit. So just like Oprah here showing you, you get extra credit, you get extra credit, you get extra credit, y'all get extra credit for free. All you have to do is solve how or show why we can take our quadratic equation, our basic quadratic equation, ax squared plus bx plus c equals 0, and how we can get to, say then, solving for x, that x equals negative b plus or minus square root b squared minus 4ac all over 2a. And, just like Oprah normally gives it out for free, I'm going to show you exactly how to do that. So, we start with our basic quadratic equation, like I said, the ax squared plus bx plus c equals 0. First thing we're going to do is just subtract c. So we get only terms of x on our left side. So that's going to leave us with ax squared plus bx equals negative c. From there, we divide by a, just to get rid of whatever term is in front of the x squared. Because we want x squared to be alone, or in, no coefficients with our x squared. So when we do that, that leaves us with x squared plus b over a times x equals negative c over a. Now, before we had bx and we divided it by a, that's the same as saying b over a times x over 1. Because then that would give us the same, that's the same answer there. So we just simplified this down then to say b over a times x. So that's how this came about. Moving on from there, next thing we do is add b squared over 4a squared to both sides. The reason we do that is because we're completing the square here. So remember, anytime we complete the square, we look at our second piece, take the coefficient in front of that, so our b over a, and we need to divide by 2, which is the same as saying times by 1/2. So when we do that, we're left with b over 2a. Then, that's what we would put into our binomial, but to find what we're adding onto our trinomial, to make it a perfect square trinomial, remember we have to take this amount and square it. So it would be b over 2a times b over 2a. That's how we'd square it, which we'd be left then with b squared over 4a squared. So that's why we're adding b squared over 4a squared to both sides. As well then, we're changing this term right here, our negative c over a, into terms of a fraction over 4a squared, so that we can combine them. That's why we're multiplying it by 4a over 4a. So we'll move this down, get a little more work in here. So doing that gives us x squared plus b over ax plus b squared over 4a squared equals negative 4ac over 4a squared. That was our original term here that we multiplied by 4a over 4a, and still plus this b squared over 4a squared. From here then, we combine our terms on the right side, because they have the same denominator, and the terms on the left side become a perfect squared binomial. So it becomes the amount x plus b over 2a squared equals b squared minus 4ac over 4a squared. Notice how b squared minus 4ac, that's our discriminant. Moving down from here, the next thing we want to do is take the square root of both sides. And that comes from our square root property. Remember, in this case, it's essentially the same as saying we have x plus n squared equals m. So we need to take the square root of both sides and then subtract the n. which I'll show you that in just a sec here. First we take the square root of both sides, so that we're left with x plus b over 2a equals positive or negative square root of b squared minus 4ac over 2a. Now we use 2a because if we applied that square root to the numerator and the denominator would become the square root of 4a squared, and we could break that down into 2a. Square root of 4a squared is just 2a. Now, from here we just subtract negative b over 2a from both sides, and that leaves us with our final answer of x being equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's how you derive the solution of x, which is the quadratic formula.